Hello everyone. Today's video is very important for all those who are preparing for JEE Advanced or JEE Main 2021. In fact, very important for the reason that the concept that I'm going to discuss today in this video is not that ordinary, not that straightforward. But yet, all of you might be knowing the concept that I'm going to uh, use in this video, but very few of very few students I've seen are able to apply these concepts in a way that is going to give you answer within 3 minutes or maybe less than 3 minutes. That is the prescribed, that is the allotted time that you get per question in your exam. So uh, let us see the question first. Many times we are asked to find the number of roots of an equation, right? And if we can factorize, if it is a polynomial equation, we can factorize it, then okay, otherwise we use calculus. But this question is combination of the two. Let us see how, and this is not that easy. Let f of x is equal to x cube minus 3x plus 1, where x is a real number. We have to find the number of distinct real roots of f of x is equal to 0. As you can see here, f of x itself is a cubic polynomial and its roots are not that easy. In fact, finding its root is really next to impossible using the techniques and the concepts that you learn in your class 11 and 12. Finding these roots, I mean, within the constraints of JEE Advanced syllabus, it is really difficult to solve this equation. Okay, to find the root of f of x is equal to 0. There are other concepts, of course. There are other concepts, there are other methods also where you can find the roots of f of x is equal to 0. But in this case, since you have to use the concepts that you learn in your JEE Advanced syllabus, so using that it is indeed not that easy. So let us first find the graph of f of x, right? What the graph of f of x is like. So for that, let us find the maxima and minima first. So I have differentiated f of x, and I got f dash x is equal to 3 times x minus 1 into x plus 1. From there, f dash x is equal to 0 gives us x is equal to minus 1 and 1, and f double dash x is equal to 6x. So from here, what we can see is that f double dash minus 1 is negative and f double dash plus 1 is positive. So f of minus 1 must be the maximum and f of 1 must be the minimum. Now what is the value of f of minus 1? So f of minus 1 is minus 1 to the power 3 minus 3 times minus 1 plus 1, which is equal to 3. And f of 1 is nothing but 1 to the power 3 minus 3 into 1 plus 1. And this is nothing but equal to minus 1. So we got the maxima, we got the minima, and this is a cubic polynomial. So for x tends to infinity, the graph is tending to infinity. For x tends to minus infinity, the graph is tending to minus infinity. So now drawing x-axis and then drawing y-axis in this case. So let's first draw the y-axis. Okay, just hold on. This is the y-axis, right? So if I start drawing, and you can see f of 0 is equal to 1, so graph is cutting y-axis at 0, 1, right? So using all this information, if I start drawing the graph, and since at minus 1 it is maxima, at 0 it is 1, and it is 1 as it is minimum, so this should be the this is the type of graph that of the function f of x, right? So let us mark the coordinates. At minus 1 it is attaining maxima, at 1 it is attaining minima. So minus 1 and 1 there. And you can see from the graph of this cubic polynomial that there are actually 3 roots of f of x is equal to 0. So for that, let us first estimate the values. I mean, not exact value, but a range in which root may lie. So for that, let us find f of minus 1, f of minus 2, sorry, f of minus 2. So f of minus 2 is equal to f of minus 1. Similarly, f of 2, if you find f of 2, what we are getting is f of 2 is equal to 3. So as you can see, f of minus 2 is negative, and minus 2 is lying on the left of the minus 1. And f of minus 2 is negative, which means this can be the possible position of minus 2. Similarly, this can be the possible position of plus 2, x equal to plus 2, x equal to minus 2, right? So we can see that the roots of f of x equal to 0, three roots are lying in, we cannot, from the graph we cannot directly find the value of x1, x2, x3, but we can okay, so we can at least approximate the range in which x1, x2, x3 lies, and from the graph it is very clear that x1 is lying between -2 and -1, x2 is lying between -1 and 1, and x3 is lying between 1 and 2. So the roots of, let us write it, roots of f of x is equal to 0 are x1, x2 and x3, and from the graph we can say that -2 is less than x1, which is less than -1, which is less than x2, which is less than 1, which is less than x3, which is less than 2. Oh. I think there is a typing mistake. It should be x3 instead of x2. I've just let me correct it. So it should not be x2, rather it should be x3. Okay, so okay, whatever, this is just a minor mistake. Okay, so let's say this is x3, right? So now what you can see is that for f of x is equal to 0, we must have f of x, either f of x, since let us say that f of x is equal to y, so we must have f of y equal to 0. So y can be, which means f of x can be x1, or f of x can be x2, or f of x can be x3, right? There are three possibilities. Either f of x can be x1, or f of x can be x2, or f of x can be x3. Okay, where x1 lies between -2 and -1, x2 lies between -1 and 1. In fact, it is lying between 0 and 1. So okay, -1 and 1, and x3 lies between 1 and 2. So how to find the roots of these three equations? So by drawing the graph of y equal to f of x and y equal to x1, y equal to f of x and y equal to x2, and y equal to f of x and y equal to x3. This is the master stroke step of the entire solution, that you actually have to find the point of intersection of the graph of y equal to f of x and y equal to x1, x2, y equal to x2, and y equal to x3. As you can see that the maxima of f of x is 3 and minima is -1, and in fact the global maxima is plus infinity, global minima is minus infinity. So as you can see that y equal to x3 and x3 is y equal to x1, first graph is y equal to x1, and x1 is this one. So y equal to x1, and x1 is lesser than -1. So if I draw y equal to x1, it should lie below the minima, a horizontal line lying below the minima. And as you can see that this line can intersect the graph at the left hand side. I could not complete the graph, I could not draw this graph towards the left, but as you can see that y equal to x1 is intersecting if I extend it on the left hand side. Similarly, y equal to x2 is intersecting at 3 points. Y equal to x3 is also intersecting at 3 points, right? So from here you can see that y equal to x1 is intersecting at one point, which of course we have to again draw this graph on the left side. That will cut at one point, and y equal to x2 is cutting at 3 points. Similarly, y equal to x3 is cutting at 3 points. So total number of distinct real roots is equal to 7. This is very clear here. And if this concept, if you remember this concept in your exam, then if you find any question like this, not only polynomial, I have chosen an example so that everybody can understand easily. So from here, I hope that if you ever get such questions, you would be able to solve the question within 3 minutes. Okay everyone, take care, see you in the next video.